In this lecture, we're going to see that we can reuse names in our inheritance hierarchy. And what we mean by that is that we can have a parent class, for example, and have a child class inheriting from the parent class, and have exactly the same names for the member variables and types, or the same signatures for functions. For example, in the parent class, you see that we have a member function called print_var. It is going to be printing some information. We can have a function named exactly the same in the child class, and C++ is going to allow this. We can also do the same things for member variables. For example, we have mvar, which is of type int. We have exactly the same thing in our child class, and C++ is going to allow this. Now, the problem is, if you create an object of child, which method will be called if you call print_var? Now, what C++ does is it is going to override or hide things you have in the base class if you happen to set up exactly the same thing in a derived class. So for example, the members in our child class are going to hide the members we had in the base class, and if we call these methods on a child object, we are going to get the versions in the child class called. If we call these methods on a parent object, we are going to get the parent version called, and we're going to see the data in the parent class printed out. This is the message here. It is possible to use the same names in both parent and child classes, and if you do that, things in child classes are going to hide or override what we had in the parent class. This is the message I want to convey here. And here is a simple example to drive home how you can use these things. For example, we can create a child object using this syntax here. And if we call a method on the child object, this is going to call the method in child. But it is possible to force the compiler to call the version in the base class. And you're going to see this syntax used somewhere in your code out there. So the syntax is to say the object name, you put it up, you say the name for the parent class, and then you call the method using the scope resolution operator here. And this is going to call the method in the parent. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is reused symbols and inheritance. We are going to just grab the template files because we are going to be building things from scratch here. And we're going to put in our files. No big deal here. And we can open this in Visual Studio Code. This is going to give us a bare minimum main CPP file. We can clean it up a little bit. And we're going to set up our parent class. Let's do that pretty fast. We're going to say parent and set up the header. And we're going to set up the implementation CPP file. We are going to set up the header file, and this is going to do everything we want. We have a constructor which is really defaulted here, so let's say default, and we can default the destructor. Can we default it? Let's do this and see what happens. And we don't really need to do anything in the CPP file. We can leave it empty. This is not going to hurt anything. And with this, we can create parent objects. Let's do that. We're going to hop over to the main CPP file and include parent and make sure that we can use that. And we're going to create a parent object. Let's do that. We're going to say parent p1 and say p1 print values. We can do that. And we can build and run this program. I think it is going to work just fine. Okay, the build is good. We can clear. Or we can set up a PowerShell window and clear and run rooster. This is going to say the value in parent is 100, which is what we have by default here. We have a simple member variable, which is of int type. It is protected because we want it to be inherited. And we have a bunch of constructors here. We have a constructor which is going to take a value, but we're not going to use that here. The default is just fine. You can use that if you want. And we have a member function which is going to print the value in parent. Now that this is working, we can set up a child class which is going to be inheriting from the parent class here. So let's do that. We're going to set up the child header file, child.h, and we're going to set up a CPP file for that, .cpp. So we are going to put the data in the header file. Again, it is nothing complicated. It is just a simple class which is going to be inheriting from parent. And we are going to have our own member variable, which is going to eclipse what we had in the parent. So the names here must be the same, mmember var. If we go in parent, it is mmember var. And what we have in child is going to eclipse what we had in the parent class. In other words, if we print the member variable in child, we're going to see 1000 printed out here. We won't see 100 that we have in the parent printed out. Hopefully this is going to drive the point home that if you have members named exactly the same, what you have in your derived classes is going to eclipse or hide what we had in the parent class. This is the message here. But even if this is the case, C++ allows us to specify that we want to grab the data in parent from a child object. For example, in our showValues method, we can print the value in child directly using mmember var, but we can also specify that we want the value in the parent class, because even if this is a child object, it has a parent part of it. So we can access the data in parent and print that if the data happens to be accessible from our derived class. And that's why we set up our member variable to be protected for it to be accessible in our derived classes. This is going to allow us to print something like this, and this is going to really work. Now that we have this in place, we can go in the main CPP file and only include the child. We can do that. And we're going to create a child object. Or we can just take out everything here and just put in the code we can use to play with these things. We can create a child object, and on this child we can print var. We're going to see that the data is going to be printed out, but we can also use this syntax to print the data in the parent part of us, and we're going to see that the data is printed out. We can also show the values and make sure we see this from a member function of the child class. This is going to call this member, and we're going to get the value in child, and we're going to get the value in parent printed out on the console. Now that we have this, we can actually try and build this. We're going to use GCC to do that. We're going to see that we're going to finish building with errors. What is the problem here? We have an undefined reference to child destructor. We didn't put in a definition for the child destructor, so let's go there and default it. We can do that. We're going to say equals default, and the compiler is going to generate one for us. And now if we build, we're going to build with GCC again. The build is going to be good. You can clear and run Rooster, and we're going to see that the value in child is 33 because we passed that in explicitly. And this is going to call the constructor we have in child. That happens to be this guy here. And you see that we are really keeping things simple. We are not calling the base constructor here. The compiler is just going to call the default constructor we have in parent here. And this is going to just work. The main message here is that you can set up member variables and member functions named exactly the same way in the parent class and in child classes. And what you have in your derived classes is going to hide what we have in our parent classes. So if we call a method on a child object, for example, like we are doing here, this is going to call the method in child, but we still have the ability to call data in the parent part of us. And this is what we do here. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.